How did they make the first program without a programming language? Hello and welcome all, hope you're all doing well. What would you say if I asked you what to do when I wanted to ask someone to do something? Normally you'll respond that you'll contact him or her. Okay, that'll do. But what if I asked you how you would communicate with that person? You'd undoubtedly tell me that you'd use your tongue. And what if I went a step further and asked you how you would tell them that? You'd say, English man, in English. The point is you'll do that in a language that you both speak. So assume you're dealing with a computer and we want to do something. What language are we going to use to communicate with it? Yep, you're right. A programming language. Programming language is a language that has been developed by a large number of computer science professionals for use in the design and manufacture of websites, phones, computer applications and operating systems. However, have you ever considered how the first machine program was created without a programming language itself in the first place? Hello and welcome, my name is Steve, and before we begin, if you are new to the channel, please subscribe and hit the bell button to receive all of our new videos. Augusta Ada Byron was born in 1815. She was an English girl who later became known as Ada Lovelace. She was the daughter of Lord Byron, one of the most famous romantic poets of his time. Ada's personality and genius became more apparent to herself and those around her as she grew older. Her enthusiasm for mathematics was limitless. What's more, she was taught by several scientists, including Scottish mathematician Mary Somerville. Moreover, because of her passion, Ada met several people who were also very interested in the same field. Charles Babbage, a well-known mathematician, is notable among them. Babbage's goal was to create a machine that could perform a variety of mathematical operations during a short period of time and without any errors. He was doing everything in his power to achieve this goal, while Ada was also assisting him as well. Thus, in the 1820s, Babbage developed the difference engine, which was designed specifically to solve simple and complex mathematical equations. The difference engine's task was similar to the calculators we use today, but there was a difference in size, of course. Moreover, the engine of Babbage's machine was not powered by a battery or solar energy, but it was powered by a mechanical engine, which was made up of a series of gears that are almost identical to the gears in a car. Unfortunately, the machine was not completed in this time because the metalworking techniques at the time did not allow for the precision that Babbage desired in his engine's parts. This in addition to the fact that making such a machine required 25,000 parts, which was so costly that the British government refused to fund such a project. Not to mention their skepticism about the invention's success in the first place, which led to the funding being halted before the project's completion. Babbage didn't give up though, as he started to work on another similar project, but with more improvements. He called his new machine the analytical engine. The analytical engine differed from the previous engine in the way it works because analytical engine was running on what is known as punch cards. These cards were just sheets of cardboard that contain numerical data as perforated holes on each sheet. Using this data, the engine can undertake the task we want it to do. In other words, we can say that those cards were the first ever old programs. Ada Lovelace, who wrote about this mechanism on which the device should operate in one of her works, is said to have invented those perforated papers. She also wrote a set of commands and algorithms that the device should use to solve a set of numbers known as Bernoulli's numbers. That is why Ada is regarded as the first programming language developer in history. And if this device had been developed, it would have been a breakthrough in human history at the time. And hey, I said if it had been developed, because unfortunately this invention was not completed during the lifetimes of Babbage or Ada Lovelace due to the cost. However, this invention was not completely lost, because it is the foundation upon which scientists have relied upon as a starting point to create programming languages that allow us afterwards to build software from computers to artificial intelligence. In the mid-1990s, with the introduction of computers, it was necessary to know how to write programs to fully utilize these devices, which means programming languages will be required to create logical programs. That is to say, they relied on the same language used in the previously mentioned engines. As a result, the beginning was extremely complicated. You might ask me right now, what languages machines needed anyway? Computer language does not understand letters and numbers in the same way that humans do. Thus, binary numbers is a language that computers understand, which has only two numbers, 0 and 1. Therefore, we arrange them in such a way that the computer can understand numbers and letters. This image you see in front of you now may help you understand it simply. As you can see, each number or letter has its binary equivalent symbol. The issue with this language is that it requires an enormous number of zeros and ones just to type one simple command. And as you may or may not know, programs are comprised of tens, hundreds and thousands of lines of codes and orders. As a result, using the binary language will undoubtedly take a very long time. This is not to mention that errors are not permitted because it may not find it if one occurred while you were writing it, or it will take you a very long time to fix it. For these reasons and more, the second generation of programming languages known as assembly or assembly language was created. Assembly language was created for the first time in 1949. With the primary goal of writing commands in regular letters rather than relying solely on two numbers. As a result, once we have finished writing the codes and tasks, they were converted into the language that the processing unit understood, which is the language of ones and zeros. And this is where the assembler role comes in, as it helps in converting the commands written in letters into the language of zeros and ones. Although this was a significant advancement in the world of programming languages, it was not without its flaws. For example, if the commands are quite lengthy, we will need a larger device's memory to store all the codes and tasks that we will generate. What's more, although the written commands were simpler than the language of zeros and ones, they were difficult to understand and remember. Furthermore, the program that has been developed or written must be compatible with the processing unit that it has been specifically designed for. In other words, the system designed for Windows will not function on the iOS system on the iPhone. Each processing unit is unique and requires a specific language to be used and run programs on it. And this is why the third generation of programming languages appeared. The Fortran programming language was introduced in 1957 as the third generation of programming language. Fortran and the other third generation languages were created primarily to assist programmers in not suffering as they had in the past. This was accomplished through the addition of some modifications. One of the first was to design languages in a way that humans can understand and abbreviate as well. For example, if there is a code that will need 8 lines in assembly language, then you will only need 3 commands in Fortran or Java. But the most important advantage of these languages is that you do not have to rewrite everything from scratch when using the program on different devices, just like it was with all kinds of old programming languages. Thus the computer became able to understand a language closer to a human language rather than the language of the machine. All of this was accomplished through the compiler, which is a program that converts a third generation language into an assembly code and then uses the assembler again to convert all commands back into a binary language. These two steps make modern programming languages understandable to us. However, its implementation is slower because the program requires time to convert the language we understand into the machine language that the computer understands. That is why the third generation was not the final step in the evolution of programming languages. After all, they are classified as procedural languages because they adhere to specific procedures and constraints, in the sense that the commands written during the program's design are intended for the computer to know only the tasks that it must perform, rather than you having to direct it as to how it will perform these tasks. And it is precisely what the fourth generation languages are used for, as they allow programmers to develop the program and define its tasks, and that is all. So they do not have to write additional commands to tell the computer how to perform the tasks. What's more, this generation's programming languages are much shorter than previous programming languages. As a result, the programmer only needs to write 10% of what they needed to write in the third generation programming languages. And with that, we're finished. If you've watched it up to here, press the like and share, so we know how many of you watched it till the end. And if you have a question in the middle of the night that's causing you confusion or keeping you up at night, please leave it in the comment section so that we can try and answer it, because we make most of our videos based on the questions you write in the comment section.